First of all, the idea for this talk was on very short notice. I tried to do my best in order to gather some information and thoughts about, or like the 5 most important implications of security in combination with HTML5. The HTML5 specification started in the beginning of 2007 already, and it seems to be an ongoing effort still, since there's still new drafts published on the W3C page. As you all know, and as we heard in Mike's talk before, a lot of applications are making use of browser components, and there's a lot of devices, as we heard yesterday, TVs use HTML. It's an omnipresent technology that got just more complicated with the introduction of this new standard, which is more and more implemented by different browser manufacturers. There's new vectors for cross-site scripting, which is the most important bit of this presentation, since it's opening way for all the other things that I referred to. There's new tags for hiding JavaScript, for example. There is mostly it's the most famous tag in this respect. It's the tag for scalable vector graphics. As you know, HTML5 is introducing a lot of support for multimedia content, and a scalable vector graphic is, as the name says, a graphic format, which you could use for hiding JavaScript inside. So that's one new thing to look for. There's also a video tag and other tags that are newly introduced that some developers do not have on their list when they do validation. And there's a new attribute, it's called autofocus. You can add that, and once the page is open, this HTML element gets focused automatically. What this triggers is the on-focus event that you might know. So once the focus is gained by that element, the on-focus method is executed, and you could hide cross-site scripting code there as well. There's a new concept which has to do with the local storage capabilities of HTML5. I will talk about that later on. That means the attacker or everybody else as an application developer could store code, stuff, whatever, on the browser side. So in the case of code, hackers or attackers could hide code which is persistently stored on the browser side. So that enables somebody like Arthur Young to implement a browser-based rootkit, which has some ports open that you can contact as a back channel and could modify or could automatically have a user interaction modified by this local code. And it cannot be detected by the server-side web application. So that might turn out a big problem, since users do not have the means yet to clean out this storage, right? You find it in many forums. People are complaining, I want to get rid of this content being stored on my browser side. The only solution at the moment is to clear out the whole cache and delete stuff, which almost nobody wants. There's a very famous concept in browsers. It's called the same origin policy. That means that JavaScript is only allowed to talk to online resources that are from the same origin. So, for the example of AJAX calls, the page is loaded, the JavaScript logic is loaded from server a.com. So AJAX calls might only go to a.com in order to be allowed by the browser. So in order to allow more resource sharing, to have that case that scripts are, for example, accessed from Google servers, which is very common nowadays, there's this so-called cross-origin request. And this has to be configured at the server side as well. So there's the server b.com, which has to deliver a certain HTTP IP header which says access control without origin a.com, since the request is originated from a.com. So there's a few more of these directives that have to be added, because in the end the browser is controlling whether this content might be displayed or not. And since this is allowing connections to other sites as well, it allows network scanning. So this is used along with the WebSockets, which I mentioned later, to contact all kinds of hosts in the same network, which you have to guess or maybe have clever means to find out. And then we have a timing-based approach. You know how long it should take for the server to respond, and there you have it, you have your network scan. Just watch the response times. So WebSockets are thought to be a bidirectional connection to the server, which is also being famous for circumventing the same origin policy of browsers. You can trick, I think that would go too much into detail, and this could also be used for network scans. Actually, there's a very good page on this. It's called Attack and Defense Labs. They have a JavaScript-based tool. It's called JS Reckon. It's andlabs.org. I forgot to put that on the slide. Then we have web workers. As you all know, malicious code is usually execute. Let's think of cross-site script. You click something or you open a page which has embedded cross-site scripting, and something happens. The attackers try to get it into a pop under or an invisible iframe for the user not to see that, and for the script to work as long as possible. So the web workers are a new concept, also introduced with HTML5, that enables JavaScript to run in a sandbox background environment. So what you have to do as a web developer, you should make sure that no user-defined content gets into this environment, since this is one of the most dangerous things to happen, that your computer is part of something else and becomes part of something else, even though there is restrictions like same origin policies. So here's like the storage, which enables the persistent cross-site scripting or the resident cross-site scripting thing. The local storage allows applications to put 5 to 10 megabytes of data into your browser. There's a session storage that, as the name says, is deleted after the current session. And there is a new database. It's a client-based database that applications make use of. And there you have all the same vectors like with conventional databases. You can have SQL injection and so on. And there's an application cache which enables applications to be accessed offline. Twitter, for example, does that. There's a so-called manifest file that defines a list of resources that should be downloaded to the client and stay there. As you might think, as a hacker, you can put in JavaScript code which is having malicious functionality, which is then always used instead of the real functions in the real JavaScript code. And also for the storage, the same origin policy applies. So that means that if you put something in the local storage, only the host with the same protocol of this application putting it there may later access it. So there's one thing you should be considering when you're using WebSQL. The name of the database that the application is instantiating locally on the browser should be random and should be associated with the user account. That makes it more difficult for attackers to access data in this storage facility, since this is one of the most dangerous things when applications make use of this. That attackers would